Hello, am I audible?
Yes, sir.
Is the screen visible?
Yes, sir.
Okay. So let us start with the numerical where we stopped yesterday. We had seen about all the different parameters, parametric effects rather, about the suction pressure, evaporator pressure, then temperatures, superheating, subcooling, all these kind of things. So let us now solve a few numericals so that you will get the idea. The refrigeration machine is required to produce the ice at 0 degrees Celsius from the water at 20 degrees Celsius. So this should make it clear in your mind that water 20 to water 0 to ice 0. Okay. Sensible heat rejection and then latent part. Fine. Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
So whenever I ask the question, either say yes or no. Till that point,
Yes,
I
sir.
have to wait.
It is fine. Yes, sir.
The machine has a condenser temperature of 298 K, the evaporator temperature of 268 K. Relative efficiency of the machine is 50%, and 6 kg of Freon 12 refrigerant is circulated. So this is R12 through the system per minute. So this is 6 kg per minute. That is m dot given 50% relative efficiency. So whatever you calculate as the efficiency, 50% of that is the actual one. The refrigerant enters the compressor with a dryness fraction of 0.6. So this is a wet compression. Specific heat of water is a standard value. Latent heat of ice is also standard value. Calculate the amount of ice produced on 24 hours. So this is basically the TR capacity asked. The table of properties for F12 or R12 are given below. So this is a question which you have to solve without the chart. And for your help, the property table is given. Okay, so you can read temperature, latent heat, liquid heat, and the entropy of the liquid. So I can make use of the same thing over here. Try to interpret the data. M 6 kg per minute, relative efficiency 50%. X, why X2 I have given? Refrigerant enters the compressor. This must be X1. X1 as 0.6. Condenser A. So my HF3 or H3 is HF3 is as same as H4. So what you've shown over here, HF2, correct? Condenser inlet is as same as condenser outlet. Here, inlet in the sense liquid part. Condenser inlet liquid, F. And your evaporator, no, not evaporator, expansion valve inlet, that is also liquid. So H3 is HF3 and H3 is equal to H4, throttling, isenthalpic expansion. So I can get Hg2 by adding this and this, HF2 plus HFG2, this and this. So Hg is indirectly given. Do you agree?
Yes, sir.
Okay. Now come to the evaporator part. In the evaporator, liquid enthalpy given, ours is the isenthalpic expansion. So naturally, this HF3, okay, is equal to H4. So this is 59, which is greater than 31. So that is a, what I can say, two-phase mixture, correct? So that is also, what I can say, very validated, correct? 31 is lesser. That is the entire liquid part.
Yes.
After expansion, what we get is the mixture. So that is 59. Fine. Okay, and the latent heat is known, so I can find out for evaporator vapor part. That is Hg evaporator. This is Hg condenser, this plus this, or over here this plus this, that is Hg condenser. Here this plus this, that is Hg evaporator. Do you agree?
Yes, sir.
And then the entropy of the liquid. So this is SF for the condenser and SF for the evaporator. So somehow I have to make use of these given properties and find out the answer. Now we are asked to solve it by using the thermodynamic equations only. No chart is given. The property values are already tabulated. So I will start. I will draw the PS diagram. Okay. It is given to me this at 0.6, x equal to 0.6. Okay. I don't know whatever is this condition. So this is a rough estimate. Okay, condenser temperature is 298, evaporator temperature is 268. And here we assume that it is the liquid part, no subcooling mentioned, right? And then further, this is my isenthalpic expansion. So H3 is equal to H4, isenthalpic expansion. Any doubt in this diagram?
No, sir.
Okay. So now I can find out H1, this, correct? Because I know HF1, I know dryness fraction, I know the latent part. Is this calculation correct? ये कहाँ से आया? This is related to the evaporator, correct? Evaporator means 268 key. So 268 key. This is my HF and this is my HFG. So HF plus X times HFG will give me H1. Do you agree?
Yes, sir.
So cross check the calculation.
Yes, sir.
Is
It
this
is
correct? Fine. Now, isentropic compression. Why this? Correct. So S2 is equal to S1. Now, for S1, I know it would be SF1 plus X1 times SFG1. Correct. But over here, I do not have any control. I do not have any information. So I'm assuming this, that it is wet. If my X2 value comes out to be greater than 1, then my assumption is incorrect. That is a superheated part, correct? But if it falls less than 1, then my assumption is correct. So I assume over here that it is a same dryness fraction part, correct? And then I will write down this. Now for this S, how you would find? Because entropy, SFG part not given. But I know S is equal to dq by T. Correct? Or rather, basically Q by T. Delta S is dq by T. S is Q by T. Correct? So I will substitute over here Q as the same enthalpy. But there is no work as such. So that is a valid assumption. So I have taken the basic help from the basic definition of entropy. See, this is SFG. What is SFG? Phase change. What is the work done for phase change? 0. Correct?
Yes,
So
sir.
entropy you can take, and for the entropy
Yes, sir.
phase change, the temperature is also constant. It is isothermal process, correct? So for the phase change, entropy can be taken as the latent heat at that particular temperature. Do you agree or not?
Yes, sir.
It is a very logical step, correct? So here HFG by T at location 2 and HFG by T at location 1. State 1. So what is state 1 over here? What is state 2 over here? Correct? 1 minute. So I can substitute for SF2 and SF1 from here. Do you agree?
Yes, sir.
Yes, sir.
Then this is my HFG for the two states and the temperatures. So everything known to me. Cross check this calculation.
Yes, sir. It is correct.
Then fine. So now this is less than 1. So my assumption that the compression ends at the wet part only is correct. Fine.
Yes, sir.
If this would have been something 1.3, then naturally this is not the proper formula. This gives me only the hint that it is a superheated one, so I have to change the formula. But now my assumption got validated. Now you got the X2 value, so you can calculate H2, correct? HF2 plus X2 times HFG2 entire part. 2 and 3 is same. That is condenser part. So this is my HF2 plus X2 times HFG2. Do you agree?
Yes, sir.
So calculate that. Fine.
Yes, sir.
So I got H1, I got H2. Now only issue is H3, which is equal to H4. But that is simple. That is HF3, liquid part, entire liquid. Correct? So that is already known to me. H3 is equal to HF3, entire liquid, which is as same as H4. So that value directly taken from the table, liquid enthalpy. This is my liquid enthalpy. Sorry, here. Correct. So this is as same as H4, isenthalpy expansion. So 59.7. So now you know H1, you know H2, you know H3 equal to H4. You can calculate the COP. Is this correct?
Yes.
What happened? There was a very weird sound. What was that?
Sir, some static, I guess.
Eh?
Some static, sir, I guess.
Static?
Yes,
What
sir.
static?
Mic खराब होगा, sir.
But what was the communication? Making
Yes,
the noise is
yes,
not
sir.
good.
ही बोला sir उसने.
Achha. So is the COP fine? Correct?
Yes, sir.
Now we are given that 50% is the actual one. So 6.8 to the half. Correct? So that is 3.41. Now there is an important step. What is given to us is 20 degrees Celsius water and we are required to produce 0 degrees Celsius ice. Correct. So let us say 1 kg of ice is there. So we can get the answer in per kg. Okay. So 1 kg into CPM into Cp into dt, that is the sensible heat rejection. That is 20 degree water to 0 degree water. And then further latent part, because 0 degree water to 0 degree ice. That is something which we want. Correct. So is this calculation correct?
Yes, sir.
And now you can realize that out of 418, major factor is 335. If you miss with the latent part, I need not even check anything further. Correct?
Yes, sir.
So now, after this, now I know COP actual, correct, which is equal to refrigeration effect divided by the work done. Now, what is the refrigeration effect? That is the mass into this, because this is per kg. So whatever is the total mass into this is the refrigeration effect per unit mass. So this will be my total refrigeration effect. And what is the work done? That is the M of the refrigerant, which is known to me. Correct? 6 kg per minute दिया हुआ है. And H2 minus H1 compressor work, which you have just found out, calculated. So the only unknown part is this M dot ice. Do you agree?
Yes, sir.
So calculate this. Is this part correct? Answer.
Yes,
Yes, sir.
it
It
is.
is correct.
Okay. And we are asked to calculate in tons and in 24 hours. So convert it. This is kg per minute. So do it for like 24 hours and then divide by 1000 to convert it into tons. So per minute ka multiply by 60 will give you per hour, then 24 hours, that is per day. And then whatever is the total answer, divided by 1000, because this is kg, divided by 1000. So we will get in tons. Is this correct?
Yes, sir.
So this is how you solve the numerical. Fine. Any doubt to anyone?
Sir,
No,
suppose
sir.
in the compressing process, if my refrigerant is going into superheated state, so
H2 will
obviously,
change.
yes, sir. So we will be accounting for the entropy change like HFG by T plus something, right? So how do we account for that?
You have to use that particular formula. Superheated entropy. Initial part is latent. जिसमें
sir.
entropy change only is related to SFG, and plus the extra part, that is that superheated one.
सर वही फॉर्मूला सर कुछ याद नहीं है सीपीटी। हाँ सर मतलब वही याद नहीं आ रहा था इसके लिए पूछ रहा हूँ।
तो रिकलेक्ट करो।
ठीक है सर।
It's a, yeah, everything attempted in thermodynamics. I'm not going to give this formula in your paper.
ठीक है सर।
ln of T sub by T set वगैरह वगैरह. Fine. Next example, 28 tons of ice from and at 0 degrees Celsius, that means only latent part, is produced per day. That means 24 hours में 28 tons, okay, in an ammonia refrigerator. And the refrigerant is ammonia, fine. The temperature range in the compressor is from compressor नहीं हो सकता, condenser होगा, 25 degrees Celsius to minus 15 degrees Celsius, because it is heat rejection. Must be typing mistake from my side. The vapor is dry and saturated at the end of the compression. So that means start is wet. Correct? And
Yes.
at the end, that means your HG. So at location 2, state 2, that is directly HG2. Correct?
Yes, sir.
And the expansion valve is used. So this means H3 is equal to H4. Assuming a coefficient of performance of 62% of the theoretical. Same logic, पहले 50% था. And nothing specifically mentioned about that subcooling or anything. So H3 is equal to H4, which is the same as HF3. Calculate the power required to drive the compressor. Latent heat is a standard part. I will not give in the paper. And the table given. Now in the table, you can find enthalpy as liquid vapor, entropy also liquid vapor. So here you need not assume for, or you need not calculate for latent part, HFG and SFG, directly given. Okay, again, interpretation of the data. Condenser temperature 25. Okay, evaporator minus 50. Temperature range in the compressor is from 25 to 50, minus 15, minus 15 to 25. Because evaporator is at a lower temperature. Condenser at a higher temperature. There is a typing mistake from my side. I should have typed it reverse way. Fine. X2 is equal to 1, dry saturated given. COP actually 62%. Latent it is standard value. And again, the same logic, I can get H2 as directly as Hg2. Correct? Then H3 equal to H4 equal to HF3. And H1 I need to calculate. Do you agree?
Yes, sir.
This is my diagram. Now state 2 is at the dry saturated. 3 entire liquid, 1 wet, and 4 whatever it comes as far as H3 equal to H4 is concerned. So H2 is equal to Hg2, ये वाला vapor, 25 degrees. Do you agree?
Yes, sir. Yes.
Now I will write down H3 is equal to H4, that is liquid part. So here 25 ka liquid. Correct? H2 is equal to
Yes.
sorry, HF2 is the same as HF3 because it is a constant pressure condenser heat rejection. Correct? So that is 100. That is taken over here. Isentropic process. And now I will use the same part. So HS2 is directly SG2. And I know that this is naturally wet. No need for any justification. So what is my SG2? This is my 2 part and SG2, this correct? Vapor 4.48. So I substitute over here 4.48. Then SF1. Now here it would be like this. Correct?
Yes, sir.
So this is my SF, this is my SG. By the way, what is the meaning of -2? How entropy is negative?
Sir, it's a system property, so it can be negative.
System property. What is that?
जैसे temperature, pressure, volume, वैसा entropy, sir.
I'm unable to grasp this.
Sir, it can be negative, sir, because it is just a property used to understand how much entropy is generated in a process. It's not like if this is negative, then it is not impossible. Sigma, if sigma is negative or the delta Si part is negative, then
Sigma
it
is
is impossible.
addition, delta is difference.
Yes, sir. So integral dp
The
by
change in entropy should be positive, then entropy itself can be negative. Right?
Sorry?
A
What is
change in entropy should be positive,
Exactly.
but the entropy itself can be negative.
You calculate the entropy value with some particular reference. So you can have the individual values positive or negative, doesn't matter. The change has to be a positive. Okay. Always remember this. You calculate all these values. Instantaneous values are always calculated with some particular reference. And as such, the value may come positive or negative, doesn't matter. When you calculate the change in the entropy, then it has to be positive. Negative entropy change is impossible, that we have already seen. Do you agree?
Yes, sir.
Just wait. Where is your chart? Let's see. Let's check the other.
sir.
Wait. Don't disturb. Wait. If I go this, I think I will get it. Yes. Ammonia. In ammonia, you can probably get it. Yes. Perfect example. Can you see this?
Yes, sir.
Yes,
This
sir.
is a chart for ammonia. Enthalpy value negative. Not only about entropy, even enthalpy value negative. What is the meaning?
This with reference to something.
Always remember this. Even though the definition says H is equal to U plus PV, that is for the ideal cases. Correct? Here you are calculating the enthalpy value of a real substance. And you can very easily say, because this side is the liquid part, this side is vapor part, ammonia gas is okay, liquid ammonia. how you can assume for H is equal to U plus PV to get validated 100%? Obviously deviation. So we always calculate these particular values, enthalpy or entropy, with reference to some particular standard, what I can say, state. If you recollect about the Kelvin scale definition, same three, thermodynamics, SY, BTech, mechanical. The reference point for the calculation was taken as triple point of what? 273.16. I hope you recollect.
Yes, sir.
गेट जो लोग गेट के लिए प्रिपेयर कर रहे हैं उनको तो पक्का याद होगा. So over there, that was the reference point. Similarly, all these charts are also drawn with some particular reference point. And what we always do by using these charts is always the enthalpy difference, correct? H2 minus H1 or H1 minus H4 or something like that. So the difference has to be positive. So it is independent of the individual values. So negative value decay. Sir, there is some mistake. No, it is not a mistake. Okay, always remember minus 1000, minus 1200. They are not incorrect values. When we go for the enthalpy difference, let's say for example evaporator load or H2 minus H1 compressor load, that difference has to be positive. Do you agree with this?
Yes, sir.
Any doubt to anyone? We are going to use this chart. At that time also again I will make you remember this point once more. Negative value is not incorrect. Okay, this is acceptable because we are taking the differences. These are not the absolute values. These are the relative values. And we do not bother about the relative values because we are interested towards finding out the differences. Fine. This is your presentation. So coming back to our part. So even though this is negative, doesn't mean as such it is a wrong one. So what I was talking about is SF and SG, which we will be substituting over here. SFG directly not known. So this is my SF part and X1 times SFG part. So I calculate this X1. This is again a typing mistake. Not X2. This is X1. Please cross check the calculation. Is this correct?
Yes, sir.
Fine. So now I got X1. X2 is dry saturated. 3 is liquid part, and that is H3 is same as H4. Correct? So I calculate this H1. That is the only part missing. H2 directly gaseous means dry saturated. H3 liquid. So only part missing was H1, which I calculated. Is the calculation correct? Acha, here also you can see. Correct. Minus 54 enthalpy. I overlooked it. That's why I showed you the chart in the table also. Minus 54 enthalpy means what? It is measured with some particular reference. Correct? You calculate the H1 value. Is the calculation correct?
Yes, sir.
So now you can calculate the COP. Is this one correct? H1 minus H4 refrigeration effect divided by H2 minus H1, that is compressor work. Is this correct?
Yes, sir.
Now given to us that 62% of this is the actual value. So 62% of whatever answer you have got is the actual COP. And I will make use of this actual COP as actual refrigeration effect. Correct? Work done. What is COP? Actual refrigeration divided by actual work. Actual work
Yes.
is H2 minus H1, you know. So this is my actual refrigeration effect. Is the calculation correct?
Yes, sir.
Now this is my actual refrigeration effect, and the total refrigeration effect I know that is 28 TR, 28 tons in 24 hours, correct? And the process of making that ice is from and at 0 degrees Celsius. So there is no sensible part involved, only latent. So 28 ton into 1000, that is kg, convert करने के लिए, into HFG, that is 335 latent part, in 24 hours and 3600 seconds per hour. So this much is the total heat extracted. Do you agree?
Yes, sir.
Now if this is the total heat and this is the specific heat kJ per kg, so I can calculate the mass flow rate of the refrigerant, correct?
Yes, sir.
So mass flow rate of the refrigerant, 108 divided by 678. kJ per second divided by kJ per kg, that will give you kg per second. Is this fine?
Yes.
So you got now the mass flow rate. And what is asked the compressor work for which the mass flow rate is required. So this m dot into H2 minus H1. Now everything you know. Is the calculation correct?
Yes, sir.
Done. You got the answer. This is the power rating, around 20 kilowatt power rating of the compressor. Clear with the example? Any doubt to anyone from the class?
Yes.
Good. Third example. In a standard vapor compression refrigeration cycle. Standard का मतलब क्या होता है? Your point 1 is at the dry saturated one, and point 3 is at the saturated liquid. Okay, always remember this. Operating between the evaporator temperature of minus 10 degrees Celsius, condenser temperature of plus 40 degrees Celsius. Okay, enthalpy of the refrigerant F12 at the end of the compression is 220. Okay, loudly given. So your H1 will be Hg1, H2 loudly given, H3 will be HF3, and that is as same as H4. Okay, show the cycle diagram on the TS plane, and then calculate COP, refrigeration capacity, and the compressor power for the given mass flow rate 1 kg per minute. Okay, and the table given. So over here, temperature, pressure से हमें कोई लेना देना नहीं है अभी, because we are not using the pH chart, we are using the TS chart. So temperature, correct, and HF and Hg. So I can calculate Hg at the inlet of the compressor. So that is this, and HF at the exit of the compressor. That means liquid part. This 74. Correct. So T condenser 40 degrees, T evaporator minus 10, X1 equal to 1. As I told you, standard vapor compression इसका मतलब compression start as a dry saturated and expansion start throttled as the saturated liquid. No subcooling, no nothing. Fine. So now I can write down directly Hg1 is my H1. Correct, this 183, since it is a dry saturated one. Then H1 is known, 183. So H1 is known. H2 directly given 220. Correct. And H3 is same as HF3, liquid part, which is 74. Do you agree?
Yes.
Yes, sir.
So almost everything is known to me. I can calculate the COP directly. Correct? So H1, Hg1, H2, 220 directly given. H4 is equal to H3 is equal to HF3, 74. Correct? H1 known. So this is my COP. Yeah, correct calculation?
Yes, sir.
Every calculation you have to cross check. Now what is asked further? COP and refrigeration capacity and compressor power. Okay. To find the refrigeration capacity, that means this. M dot into H1 minus H4. Correct? Now H1 is Hg1, I know. H4 is same as H3, which is HF3, that is also known. And mass flow rate given 1 kg per minute. So this is my refrigeration capacity, directly calculated. Do you agree? Is this calculation correct?
Yes.
Fine. And the compressor power. Compressor power is related to H2 minus H1. Mass flow rate is 1. So H2 220 loudly given. H1 is Hg1 183. This gives me the compressor power. Is the calculation correct?
Yes, sir.
Okay. This is kg per minute converted in kg per second so that you will get kilowatt. Fine. Next example. Now you can see the table. बढ़ते जा रहा है. So here we are having temperature, pressure, volume part also. Then enthalpy liquid, enthalpy vapor, entropy liquid, entropy vapor, and specific heat is also. So this gives me the hint. ये आ गया VG. इसका मतलब compressor performance, volumetric efficiency. Okay. I can play with it the way I want because it is a suitable and valid assumption that you are done with this thing in your thermo or IC engine or any kind of course earlier done. Freon to oil refrigerator producing the cooling effect of 20 kg per second. Operates on a simple cycle. Simple means same. State 1 is dry saturated vapor. State 3 is saturated liquid. Okay. Pressure limits of 1.509 bar, 9.607 bar. Either the over. Corresponding temperature is important. The vapor leaves the evaporator dry saturated, very loudly given. That is the inlet to the compressor. Okay. And there is no undercooling. Undercooling is same as subcooling. So that is why we call it as a simple cycle. See? Determine the power required by the machine. Power required means compressor power, correct? If the compressor operates at 300 RPM and has the clearance volume of 3% of the stroke, that means volumetric efficiency, determine the piston displacement of the compressor. Pi by 4 into d square into L into volumetric efficiency, correct? For the compressor, assume that the expansion, compressor and expansion. Why expansion? No, compression process follows the law PV raised to 1.3. So N is given, it is not gamma. Okay, so you can calculate the volumetric efficiency. For that, you need that N. Na?
Yes, sir.
Correct. So pressure ratio known, N known. You can calculate volumetric efficiency. Right. So here, majority of the properties are given. What is the interpretation of data? 40, then evaporator minus 20, X1 is 1, then H2. ये कहाँ से आ गया? This is wrong. Copy paste. Control C, Control V. The earlier example. Fine. 74 हाँ ये तो इस example का ठीक है. So H1 is directly taken by say enthalpy, yes, 178. So that is why 178. Correct. Then H2F or H3F, that means 40 ka F, 74. Okay, so that is taken here. Correct, and that is as same as the isentropic expansion. Any doubt to anyone?
No, sir.
Good. So we'll try to plot it. Same diagram, correct? Simple cycle given, standard. Right? Now I will try to find out one by one. Refrigerating capacity. What is given to me? 20 kg per second. That means 20 kilowatt. Correct? Is equal to m dot into delta H. I don't know m dot value. That is the only missing part. And H1. H1 is this. Hg1. That is 178. Correct? H4. That is same as H3. That is liquid part. HF3. 74. So I can substitute and calculate only the unknown part, m dot. Is this calculation correct?
Yes, sir.
Good. Then isentropic compression process. Hemant, ले लो formula. So S1 equal to S2. Correct? S1 is directly SG1 and S2 is superheated. So this is S2 dash plus Cp times ln of T sup by T sat. So I get the superheated temperature. Correct? Cross check the calculation.
Yes, sir.
Nick, logic is correct. Calculation also should be correct. Cross check. Is T2 fine?
Yes, sir.
Now you got T2. So you can substitute and calculate H2. Enthalpy was also superheated, right? So here it is Cp delta T. For the entropy, it is Cp into ln of ratio of temperatures. Here it is temperature difference. So इसका saturated value पता है from the table. 40 degrees का saturated value Hg 203. उसके ऊपर so 203 plus Cp और उसके लिए ये Cp दिया है specific heat. Okay, so 747 substituted over here. T2 and T2 dash. T2 dash is standard, means given already. And T2 you have found out. So you got the H2 value, superheated. In the earlier example, it was 220 directly given. I tried to cover the variety of examples so that you can get the glimpses of how to use, whether it is given like a known or the unknown. If it is known, you are fortunate. If it is not known, you can calculate. Is the calculation correct, H2?
Yes, sir.
Good. So now you got H2, you know H1, H4, everything known. And calculate the COP the way I want. Now the power required. What is power required? M dot, which you have just calculated. Correct? 20 kilowatt ke hisab se. And H2, H1 just now calculated. So substitute. Is the answer correct? 211 is H2. Yeah. And H1 is Hg1. Correct? 174 or something. 178. So this is my power required. Is the calculation correct?
Yes, sir.
Now the volumetric efficiency. I hope you recollect this correctly because you have to. No choice. So K, that is clear, that is 3% given, and 1 by N. N is that PV raised to N. Wala. Is it 1.13 or 1.3?
1.3.
So please cross check whether this is a typing mistake. 1.13.
Sir, you have calculated, I guess, using 1.13.
Acha.
Using 1.3, it is 90.54%.
Oh, I see. So that means this is
So 90.54.
So this is 1.13, correct?
Yes, sir. You have taken the wrong value.
Me, I have taken correct value. I might be like, I might have misprinted over there at the given condition. Otherwise,
Okay.
अगर 1.3 बराबर होता तो मेरा calculation बराबर आ जाता. This would have been a typing mistake, not a calculation mistake. Fine. So my typing mistake in the given. Okay. Now you get the volumetric efficiency. Volume of the refrigerant at the intake. How do you calculate mass flow rate into the specific volume? Correct. And that is at intake. So that is
Yes.
Vg1. And what is Vg1 given to me? This is minus 20 evaporator. So that is 1. So that is why this Vg1 is given. Correct. So I will substitute over here. So m dot you have calculated. जो यहाँ पे लिया हुआ है earlier 20 kilowatt. And this, so this will give me the volume. And now I have to equate this by considering this volumetric efficiency along with the standard formula pi by 4 d square into L. Right? So this is my piston displacement. Actual volume divided by volumetric efficiency into RPM. Actual volume in the sense, I should not say actual, theoretical. So this is what is the piston displacement. The RPM hai per minute, so I have to take 60 into consideration. Because this is per second. I have to convert it to minute. So multiply by 60. That will give you per minute. And this is revolution per minute. Correct?
Yes, sir.
So this is how you got the piston displacement. अब मैं क्या करूंगा इसको और ट्विस्ट करूंगा I will give you L by D ratio and I will ask you to calculate the bore and stroke. Correct? Key. So I can twist the numerical the way I want. 20 marks numerical. Use pH chart and then find out the piston, bore and stroke with the given volumetric efficiency. इसका मतलब second year to fourth year, everything you have to recollect. Basics of RAC, basics of compressor, basics of volumetric efficiency, everything. Correct? So this way I can set the numerical. Compressor आपका हो गया.
सर कंप्रेसर कौन से इसमें पढ़ाना था वैसे?
क्या?
मतलब सर ये बात जब कुलकर्णी मैम ने आईसी इंजन लिया था तभी भी सेम बोला था मैम ने कि तुम्हारा कंप्रेसर हो गया होना चाहिए और मैम ने भी न्यूमेरिकल्स में सीधे फॉर्मूलेज ही यूज किए थे.
I don't know आपके fluid mechanics में हुआ होगा. Compressor is shifted over there. Or maybe in IC engine, I don't know. Earlier it was in thermodynamics. Then removed.
Yes sir. तो उधर फ्लूइड मैकेनिक्स में सिर्फ सेंट्रीफ्यूगल कंप्रेसर यूज पढ़ाया था सर.
Let it be. In your gas turbine, उसमें सब compressor है ही ना.
हाँ सर, तो उसमें मैम ने बोला कि यू मस्ट हैव ऑलरेडी स्टडीड कंप्रेसर और मैम ने सीधा n into n minus 1 into वो वाला वर्क का फॉर्मूला लिख दिया था और
See, I don't know to which part it is shifted. I can find it out. Earlier it was in thermodynamics. Then I think it is shifted in IC engines only. Compressors and gas turbines are coupled because without compressor you can't solve gas turbine. So I think it was, or it is supposed to be taught in that particular course only. I don't know. Either in fluid mechanics or in IC engine.
फ्लूइड मैकेनिक्स में सिर्फ सेंट्रीफ्यूगल कंप्रेसर लिया था सर ने लास्ट में, गुनादाल सर.
सेंट्रीफ्यूगल व्हाई? रेसिप्रोकेटिंग का क्या हुआ?
रेसिप्रोकेटिंग पहले रेसिप्रोकेटिंग पंप लिया है, कंप्रेसर नहीं लिया है.
नहीं, देन दैट इज अ प्रॉब्लम. क्योंकि अभी देशपांडे सर ने लिया ना पूरा रेसिप्रोकेटिंग कंप्रेसर एंड उसके बाद सेंट्रीफ्यूगल. दैट्स व्हाई कुलकर्णी मैडम must have said because compressor part is shifted in fluid mechanics.
अच्छा.
Without compressor, how you can solve for gas turbine? In the gas turbine also there is a air compressor. It must have the efficiency, it must have the piston displacement, means bore stroke, everything.
सर वो इतना डीप डेप्थ में नहीं था ना, मतलब आईसी पहले गैस टरबाइन अलग से पढ़ाते थे ना सर.
Gas turbine earlier was in again thermodynamics. Earlier there were two thermodynamics, SEM 3 and SEM 4.
यस सर हाँ.
तो उसमें कंप्रेसर, गैस टरबाइन, स्टीम टरबाइन ये सब एक साथ.
यस सर.
Then as per
अभी
the
मैम ने वो
government
लास्ट में
norms, 194 क्रेडिट्स का कम करके 164 क्रेडिट्स करना पड़ा. 30 क्रेडिट्स उड़ाने थे. तो 4 क्रेडिट का एक कोर्स, 3 क्रेडिट का एक कोर्स ऐसे करके उड़ा दिया. उसको इधर उधर डाल के स्क्वीज कर दिया. That was the problem. Earlier there were thermodynamics 1 and thermodynamics 2, or FTD and ATD.
Yes.
Fundamentals of thermodynamics and applied thermodynamics.
Yes.
So I only used to teach all these things, compressor and then gas turbine. अब compressor शायद fluid mechanics में डाला, gas turbine in IC.
ठीक है.
compressor आपका ढंग से हुआ या नहीं हुआ?
सर ये फॉर्मूला सर मतलब क्लास में तो पहली बार हुआ है, वॉल्यूमेट्रिक एफिशिएंसी वाला 1 + k - k. क्यों
आपका रेसिप्रोकेटिंग कंप्रेसर हुआ नहीं इसके लिए?
हाँ.
You don't know the derivation of this formula.
नहीं मतलब हाँ मतलब मैं सर हमने तो पढ़ा है अभी गेट वेट का, बट बाकी क्लास तो नहीं.
तो बाकी क्लास चुप क्यों है? Why they are not telling? Those who are not preparing for gate. देखो इसका मतलब बाकी सबको आता है, इवन तो किसी ने सिखाया नहीं फिर भी आता है. ऑटोनॉमस स्टूडेंट्स. Nobody is raising this objection. Good, then I'm free.
ठीक है सर.
That you know compressors. I
चलेगा.
was under the impression that compressor is properly taught to you maybe in fluid mechanics course, and then you have already employed all these things in the gas turbine. मतलब I think in SEM 6. So that was my assumption. You are saying that it was not properly taught, but nobody other is ready to raise this objection. So that means they are happy with this thing. No objection. I'm more happy. Yes, CR or anybody else.
Yes,
Do you
sir.
have any objections?
So मतलब अभी नहीं सीखा तो क्या कर सकते हैं? Objection
I
करते
will share. I will share my notes, which I used to teach in the old syllabus. I have my notes ready. I will share the PPT. You can go through that and prepare. What is so difficult to me? If you want to
Yes, sir,
discuss
that would be
for any
helpful.
particular bit, I can always discuss through the lecture. I will not teach that entire chapter because that is not my concern now. But I can always share the notes. You can go through the notes and see. If you get everything clear, very good. If you do not get, then we can discuss about that particular bit.
Yes sir, we can do that.
Yes, sir. आप शेयर कर दोगे तो वही फिर अगर if we have any doubts तो we'll ask you.
I will share my PPTs. Fine. Okay. So should I move ahead? Share time काय बाबा?
So 12:10.
हाँ म्हणजे 5 मिनिटं राहिली. So let us finish this example. This also is yes, TS only. ठीक है. Food storage locker requires refrigeration capacity of 50 kilowatt. Fine. Refrigeration load no. It works between the condenser temperature of 35, evaporator temperature -10. Refrigerant is ammonia. It is subcooled by 5 degrees Celsius. So here subcooling is done. I tried to collect the examples in such a way that every aspect will be covered here and there. So volumetric efficiency हो गया, superheating हो गया, subcooling हो गया. Okay. Subcooled by 5 degrees Celsius before entering the expansion valve, okay, by the dry saturated vapor leaving the evaporator. So evaporator exit is dry saturated. Fine. Assuming a single cylinder, single acting compressor operating at 1000 RPM with a stroke equal to 1.5 times the bore. अभी आपको आता है या नहीं आता? Should I take this example or not?
नहीं सर, ये नहीं आता है.
So then I will teach you this in the next. किती? 2 वाजता. 2 o'clock. I was assuming कि आपको formula पता है, but वो पता नहीं है. तो at 2 o'clock we will deal with this example. An immediate next example is with respect to the pH chart. So please keep the pH chart, means that ASHRAE handbook ready with you, which I shared yesterday. Okay.
Sir, if you're free, you can take this lecture right now also. We don't have a lecture right now. Instead of 2
Why so?
o'clock. Piping
What
lecture
happened
got cancelled. So.
Acha, piping. Okay. But I have made some plan. I have to procure some material in the college, REC lab, and for that I had planned to go for
Okay, fine, sir. We can have it at 2 also. No problem.
No, otherwise you give me 5 minutes only. I will cross check because I have to go for the signature. But if the person is not available for signature, then it is like wastage of my time also. So just let me check and then I will continue. So I will share the link if required after 5 minutes. Okay, 5 or let's say 10 minutes. And if within 10 minutes, if you don't get anything, then at 2 o'clock. So I will share the message accordingly with CR.
Okay, sir. Okay, sir.
Fine.
Okay, sir.
Should I end the meet at this moment?
Yes.
Yes, sir. Yes, sir.
Okay, fine. Sure. Thank you.